everybody, and welcome back. Today we are going to be looking at triangles and putting triangles into this. Yes, a circle. What happens when we start putting triangles into circles? We're going to go over some really cool laws. Let's get to the math action now, shall we? Here we go. Triangles. We love triangles, don't we? There's going to be so many different things that we're going to be looking at today. We're going to be looking at triangles today. And we're also going to be looking at what happens when you start looking at angles and some triangles inside circles. So those are the two things that we'll be looking at today. Some common things that you guys hopefully will know is that inside a triangle, all the angles inside add up to 180 degrees. That's pretty important to know. There are different types of triangles. Of course there are. There's the good old famous right angle triangle. That little box means that that is, of course, 90 degrees. There is the isosceles triangle. An isosceles triangle has two sides the same, and to indicate that, we have those little signs there, little lines. One thing I always like to show students, an isosceles triangle also means that the opposite sides angles are equal. So I always draw little arrows like this. So this arrow, kind of work with me here, it kind of hits that one, so we'll say that's X, and that's also X. And those were official sound effects from the upcoming Star Wars film. So those two angles are always going to be equal. And what other kind of fun things do you guys need to know? Oh, this one's always a fun one. Hopefully your teacher has shown you this little law here, the outside angle, and we'll call that X, is equal to the sum of the two opposite interior angles. We'll call those Y and Z. So we can say X is equal to Y plus Z. So those are kind of some of the triangle stuff that you guys sort of have to know, and combine that with your other knowledge of straight lines. So, you know, straight lines, imagine that straight. You know, those add up to 180 degrees. And of course, you guys know that circles, yep, that's my attempt at a circle, is 360 degrees. So using all of that knowledge, let's get into some questions, shall we? And if you don't want to, I guess you can just hit stop on the video if you really wanted to. So first off, here we go. Let's start off nice and easy. Let's just say that we have an isosceles triangle here. Boom. There we go. And I'll say this is 20 degrees. And I'll say this is 4x. And I'll say this is y. And basically, this can be rewritten. So when you see this, a lot of kids think that 4x and y are different. Well, you know by isosceles triangles that those are actually the same. So this and this are exactly the same. So I'm just going to redo this and say this is 20, this is 4x, and this is also 4x because it's an isosceles triangle. So we can make an equation where we say 20 plus 8x, I combine those two 4x's, is equal to 180. So 8x equals 160. So x is going to be 20. And of course, if x is 20, I put 20 back into there. That means that both of those angles are going to be 80 degrees each. So just using some algebra and some knowledge of triangles. How about this one? Here's a fun one. So we're going to use our knowledge of vertically opposite angles. And we'll call this angle 120 degrees. We'll say this part here was 50, and we'll say this part here was 94. And I want to know way over here how much x will be if that little corner is 3x. Well, a couple of things. You want to look at vertically opposite angles. So you know that this entire thing is vertically opposite to this 120. So if this part here is going to be 50, then you would know that this part here would be 120 minus 50. So that would be 70 degrees. Okay, well that's exciting. And by straight line laws, 94 plus this green angle would have to equal 180. So to get to there, that would have to be 86 degrees. Now you have a triangle that you know a lot about. So you have this triangle that you know this is 70, this is 86, and this is 3x. And you know that the entire triangle has to equal 180. So you would get 70 plus 86 plus 3x would equal 180. And then you do a bunch of math. Just do the math. So you'd take your 180 and you'd probably go and subtract that 70 and 86. So you do all that and you get 3x equals 24. So x would then be 8. Boom. There you go. And again, always make sure if your teacher wants you to tell you what the angle is equal to or what x is equal to. That is pretty important. So 3x equals 24 or x equals 8. And there you go. So let's take a look at when you're combining all of your geometry knowledge to date. So here's a couple of lines. And we're going to say that those two lines are parallel. Pretty exciting. And then we're going to go and build an isosceles triangle. I'll try and make it look kind of... that looks pretty bad, doesn't it? Let's try and make this a little better. There we go. And I'm going to call these isosceles triangles. I'm also going to make these be isosceles triangles. Pretty cool. And then I'm going to go and add in some more information. I'll say that this entire angle is 80 degrees. So it's both of this all together. This entire thing is 80 degrees. And I'll say, let's go and find this, x. Okay. Here we go. Do you see where we can extend lines? So let's go and extend lines. Let's be good math students. Remember you had that really cool math teacher that told you extending lines was really important. So I'm going to extend lines, and I'm really hoping that you see the transversal. This is the transversal, in case you guys don't see it. So it's a transversal. So we can start using transversal laws, which is pretty cool. So that means if this is 80, that means this part here would have to be 100 degrees. So we know that because this whole thing makes basically 180 right inside here. So this whole thing has to be 180. And that means that this is going to be 80 degrees, like that. So that lets us start to go and do some other things as well. Is that if this is 100 degrees, and this is an isosceles triangle, this one right here, that means this angle and this angle must be the same. So that means they have to be 80 degrees altogether. So they'll each be 40. Using the power of isosceles triangles. So if this is 40, then the other piece over here is also going to be 40. But more importantly, we also have this being an isosceles triangle, which means way over here is going to be 40. So now this giant triangle, and maybe I'll make it a different color, make this giant triangle. So this triangle looks like this now. This piece is 40. This piece is 40. And way up here, this is 40 plus x. Well, we know the entire triangle has to equal 180. So we could get 40 plus x plus 40 plus 40, and that all has to equal 180. So we're going to get 120 plus x is 180. So x will be 60. Pretty cool question, using a lot of different things at once. Now let's shift gears a little bit. Let's get rid of this stuff and let's start talking about circles. Circles are awesome, and we all know that circles add up to basically 360 degrees. But there's some really neat things that happen with circles. A couple things is that I'm going to talk about basically inscribing stuff. So when I inscribe something, so say I inscribe this right here, and I'm going to just make these points just so I can talk about them a little bit. This point right here, this one right there, that's called the apex. And the other points are called the endpoints. So these kind of 2 points here are called the endpoints. And of course, we make a kind of an angle right here. Well, we're going to talk about some different kind of angle laws that happen with circles. Where should we start? Let's start with a really, really cool one with the angle center theorem. So the very first one is going to be the angle center theorem. And it basically says this, is that if a triangle is formed going through the center of a circle, you get a really cool thing that happens. Now normally, if we were going to do this, we'd all kind of go and try this with our compass, make a circle, and then see what actually happens. So I'm just going to go and make a triangle that's going to go through this. So there's one side. So now I need to make a triangle. Well, I'm going to go maybe like this, and I got to connect it. So there we go. Now when you do this, which is really, really cool, when you do this, if you inscribe a triangle that goes through the center point, you automatically will get a 90-degree angle. Yes, you will get a 90-degree angle. And I didn't draw this very well. So there we go. It's a little bit better. You will get a 90-degree angle. And for right here, just because I was just doing this one, here's your 90-degree angle. If you try this, it would actually be more obvious, but this is going to be a 90 degrees. And that's what we always kind of get. So how could you go and, I don't know, get a question like this? So what would an example look like? An example might look like this. So here's a circle. Here's a little point. And let's just say you had a triangle that was kind of going like this. So very, very similar. And I was told that this little point, I'll use maybe a different color, that right inside here, right inside there, was 26 degrees. And I said, I want to go and find out what is this one right here. What's this? X. Well, you're not told that this is 90 degrees, but because of this theorem, just trust me on this is 90. So now the math is actually really easy. It's just going to be 90 plus 26 is plus, obviously 90 plus 26 plus x, oops, would equal 180. So you just go and you solve that one, and that one won't be too bad. You just, you grab your handy dandy calculator and you go 180 and you minus 90 and 26, and you get 64. So that's the first theorem that we're going to talk about. That's inscribing a certain kind of triangle. We have two more that we're going to be looking at. The other one, so let's go and try and draw a circle. And I love this lesson because I think it's really, really cool, but I also hate it because I have to draw circles, and I'm not very good at drawing circles. But that's okay. Embrace the things that you're not good at. And here's what we're going to say. This one is called another one, and we're going to call it the angle at the center. So angle at the center. And for this one's pretty neat. So here's my dot, marking the center point. And if you basically have two fixed endpoints that kind of are stemming from the center, like that, and you go, oh, that's a horrible. Let's make this a little better. That's much better. There we go. This is what we say. That this angle here and this angle here are in a relationship. Yes, they're dating. No. If this is, we call this x, this one is always going to be twice the size. So that's really, really neat. No matter where it is on the circumference of the circle. The angle is always twice that. So for instance, if you had an example, that kind of looked like this. Here's a pretty good circle. That's pretty good. That's a pretty good circle. And remember, so if you have two kind of endpoints kind of going like this, and if you go and bing, if that hits anywhere in the circumference, you basically create a very interesting situation. So we'll call this x, and I'll say this is 98 degrees. You know that x is half of 98. Half of 98. So if you just divided 98 by 2, you would get x. So then x, I think that would be what, 49 degrees? 49 degrees. Okay, so that's law number 2. We need another law. We need the third one. The third law will look like this. The third law is probably a pretty challenging one. So law 3 is angles subtended by the same arc. Let's see if we can go and look at this one. What does that mean? Here's my circle, and it's a pretty bad circle, but you know. So there's my center point. This one doesn't even involve the center point. So I kind of put the center point there just to make this very, very obvious. And basically, it's kind of fun to draw this one, though. I like drawing this one. So say if you have something that happens like this. So that goes over there, and this goes down, and this jumps up to there. Boom. Well, you get a very, very cool relationship. And the relationship you get are these two angles will be equal. And they're basically sharing a same arc. The arc, which is basically they're sharing, is going to be right here. They're kind of sharing this arc right here. This is kind of the arc that they're sharing. So they're going to be those that are going to be equal. So what would that look like for an actual question? Here we go. This is all circle stuff with like cool triangles. Here's my circle. It's more like an oval. I'll put the center in there just to make it obvious that the center doesn't really play a point in this. And let's go and do this. And I'll go cutting over here. And I'll draw over here and back out like that. And let's go and call these things. We'll call this, and I'll use maybe a different color. Maybe I'll use some yellow. I'll call this V, and I'll call this W, Y, and of course good old X. And you're like, where's Z? Where's Z? We'll say this is Z. So we'll say this point right here is Z. Like that. And there's X right there. Okay. And let's throw in some numbers here. We'll say that this is 72 degrees right here. 72. And we'll say way down here is going to be 38. 38 degrees. And what I want to know is, what is angle VZW. VZW. So VZW. VZW. I want to know, what's this angle? That's what I want to know. Okay. Well, let's go and plug in some stuff. If this is 38 degrees right here, this is 38 degrees. Is there another 38 degrees somewhere? I think there is. I think 38 degrees will be right here. And once you know that, once you use this law, that's pretty cool, because now I can go and actually solve this one, because now I have a triangle, right? I mean, triangles add up to 180. So if you just take 180 and you subtract the 72 and the 38, I think you get 70 degrees. And there you have it. So there's some really cool laws that kind of work with triangles being inside circles. Hope you enjoyed. Thanks everybody, did you get the point? Geometry jokes are great. Thanks for tuning in. Go subscribe, down there, you guys know the drill. You're probably already subscribed, but if not, think of how exciting it'll be if you are the person to get me to 100 subscribers. Yes, you can help me out. Thanks so much. Until next time, have a great day.